our cooking show. We're making lofthouse cookies while using the scientific method. The scientific method is a way of learning that emphasizes observation and experimentation to understand the world. Key characteristics of the scientific method are observation, formulation of hypotheses, testing of hypotheses by experiment, and the formulation of laws and theories.
First, one must observe or measure some aspect of nature. Next, the scientist forms a hypothesis, or tentative interpretation or explanation of the observations. Because good hypotheses are falsifiable or potentially wrong, they are tested by experiments. Results either confirm the hypothesis or show the mistake that must be modified. The scientific method is the basis for all chemistry, science, and life. We use the scientific method in developing our own experiment for our cookies. Our hypothesis is that using bleached cake flour instead of all-purpose flour will cause our cookies to be less dense or fluffier. We formed our hypothesis after doing research and are testing it out with multiple trials, which will reveal whether or not our hypothesis is correct. We will then do more trials, get it peer-reviewed, and share our results to the science world. Our hypothesis was proven correct because cake flour had the greatest average percent difference in height at 70.2%, meaning it was the fluffiest.
All-purpose flour, our control, had an average percent difference of 58.8%, and bread flour had the lowest percent difference with 47.6%.
So we have 3 bowls right here, and these are one for each of our trials.
So we're trying to change the density of our cookie by changing the flour, the type of flour we're using. But I don't really know what density is. Oh no!
Okay, so Hallie, density is the ratio of an object's mass to its volume.
Oh right! When one substance is less dense than another, it means that the object has less mass in a given volume. On an even smaller scale, a particle level, this means that the object has fewer molecules in a given volume. Density is commonly measured in grams per centimeters cubed or grams per milliliter. Because the unit of measurement of density is composed of mass divided by volume, you can convert an object's mass to its volume and vice versa if you know the object's density. In our experiment, our goal is to get a less dense cookie, like I said, by changing the kind of flour we use. A fluffier, taller cookie would mean less dense cookie because fluffier means more air in the cookie, which means more volume, making for a lower density. We want a lower density because this will mean a lighter cookie, more volume, and less mass per each unit of volume. Now that we've finished the sour cream, we're going to add eggs.
Egg time!
So we're doing 1.5 cups of each kind of flour. And
so she's dealing with different chemical compositions, which are the makeup of chemical compounds, and they are made up of elements that are combined in fixed, definite proportions. That's what a chemical compound is. So the law of constant composition states that all samples of a given compound have the same proportions of their constituent elements. Compounds used in reactions to form new things because of their specific properties and compositions. Because a given compound always has the same composition, it can be used in things like cooking. One very common compound that is often used in recipes is NaCl, or table salt. So if you break down a 58.44 gram sample of NaCl, you're going to get 35.45 grams of chlorine and 22.99 grams of sodium, or a chlorine to sodium mass ratio of 1.54 to 1. This ratio is the same for every single sample of NaCl. Knowing a substance's chemical composition is important, especially in cooking, because different ingredients made up of compounds may react negatively with each other. Knowing salt is actually NaCl would help because one could check to see if it would react badly with other compounds in a recipe. Along with this, each individual compound's composition contributes to the overall composition of the recipe. The batter itself has its own specific composition that should not change. This is why different types of batter, like brownie batter versus cookie dough, for example, have different properties such as texture, taste, viscosity, and appearance. It is important to make sure you include the correct measurements of all your ingredients so the composition of the batter does not change. So, also, when you're adding your ingredients, something to remember is that a limiting reactant is the reactant that determines the amount of product formed in a chemical reaction. You can find the limiting reactant of a substance by using the original amount of one of the reactants that goes into the reaction and using math and conversion factors and the reactant's mole ratio to see how much that reactant would produce in the end. Doing this for each reactant and seeing which one produces the least amount of product shows the limiting reactant and tells you the theoretical yield of the reaction, which is how much the reaction should produce. In our experiment, every reactant is limiting because there is no excess of any reactant in the end product, meaning they are all used up completely in the reaction. Most recipes are designed to form a specific amount of end product, which requires a certain amount of each reactant. Therefore, as recipes are made, the minimum amount of each reactant needed to reach that final end product is recorded, and that is why there are sometimes what may seem like odd measurements of some ingredient. Accidentally measuring the wrong amount of an ingredient, maybe by reading your measuring device incorrectly or not being exact in your measurements, could affect the actual yield, which is how much the reaction actually produces. So this is why you have to level out the flour before you put it in and make sure that you're getting the exact amount of an ingredient. It is very important to make sure you use the correct measurements of each ingredient.
This is sifted, it's beautiful. They didn't have bleached bread flour, so all they have was unbleached.
So that's just what we're going to have to make work.
But it shouldn't affect too much because
we already predicted that one would be the worst.
And the different kinds of flour, the reason we're using them is because they have different amounts of protein in them, which reacts differently with the water, creating more or less gluten. So the unbleached or bleached shouldn't affect how much protein the bread flour has in it.
But it might affect the color.
Yes. So
according here.
Yeah. Okay, so you can kind of see this is how this looks.
Yes.
Okay, and then this is the cake flour. The last one I showed was the all-purpose. And then
our bread flour.
Here's the bread flour.
You really can't even tell a difference in its color unless... it looks so good.
Okay.
Look at it!
So pretty. Okay, I'm gonna wash. This is really kind of weird because it's a lot thicker.
Actually, a lot more
this versus these two. So this is the cake flour.
It's super whipped looking.
And then this is the bread flour. It's so dense.
And then this one is in between. This is all purpose.
We can already kind of see a big difference. So this is it reacting with the water and making gluten, which makes it thick.
It's cookie sheet time.
You can really see the difference. Here's,
okay,
oh gosh.
This is cake flour.
This is the bread flour. So the temperature of the oven is at 350 degrees, and temperature is a measure of thermal energy, or more specifically, the movement of particles. Heat is the transfer of or exchange of thermal energy, which is caused by a temperature difference and measured in joules. Temperature is measured in degrees Celsius, degrees Fahrenheit, and Kelvin. When two objects have a large temperature difference, for example, cold water and a hot pan. The pan and the cold water will exchange thermal energy, mostly the cold water absorbing the thermal energy of the pan, in an attempt to equal out the temperature. This exchange of thermal energy with the goal of thermal equilibrium is heat. So the reason our cookies will be hot when they come out of the oven is due to an exchange of energy when in the heated oven. The pan is heated by conductivity. The energy applied to the molecules from the heat causes them to vibrate, increasing their kinetic energy and their temperature. The hot air comes in contact with the cookies, and the molecules of air have high energy, and by coming in contact with the molecules in the cookie, it transfers this energy, heating the cookie. The air inside the oven is hot, but the cookies are not when we put them in. So there's a temperature difference which causes an exchange of thermal energy between the cookies and the air surrounding it. The temperature change of the cookies is directly proportional to the amount of heat they absorb from the oven. This exchange of thermal energy is what makes the cookies hot when they finish baking.
Batter sugar! Yay! Look how cute this little bowl is.
Okay, so icing right now is a solid because it's in the powder form. And that's a state of matter. So matter is anything that has mass and takes up space, and there are three states of matter. There's solid, liquid, and gas, and this one is solid.
The main difference between the three states of matter is the arrangement of their atoms or molecules. The molecules of a solid are packed very closely together so they can't move around each other. The molecules of a liquid are still somewhat close together, but unlike solids, they are not so close that the molecules can't move around one another. This is what allows liquids to flow. The molecules of gases are spaced out and can move around each other freely, and unlike liquids, they are not close enough to each other to have a definite volume.
The cookies began as a dough, a combination of liquids and solids, also called a homogeneous mixture. The dough is very wet, so when the cookies turn out solid after baking, it is because the water found in the liquid components of the dough, butter, sour cream, and eggs, evaporated when the cookies were heated in the oven. When water reaches its boiling point of 100 degrees Celsius or 212 degrees Fahrenheit, it begins boiling and evaporating until all the water evaporates. When we make icing, we cream together butter and sugar, making a homogeneous mixture because the ingredients are evenly distributed throughout the mixture. The icing at this point has liquid characteristics in that it does not have a defined shape, and the molecules will move around each other when stirred. The milk mixed with the icing gives it a more liquid-like consistency the more we add. Before adding milk, the icing is too thick, so we will add a bit to thin it out, but not too much because we want our icing to be thicker with more characteristics of a solid than a liquid, so it won't run off our cookie. Using states of matter, we can manipulate the texture and consistency of our cookie. Oh no, it won't stop. So, these cookies show signs of a chemical reaction. So signs of a chemical reaction include a change in temperature of color, light emission, and or the formation of a gas or a solid. So that would indicate like bubbles.
In chemical reactions, atoms can combine to form new compounds, molecules can decompose, or atoms of one molecule might switch with another. When these reactions occur, there is usually evidence of it. Physical evidence is not always conclusive. For example, when water boils, there are bubbles, which would indicate the formation of a gas. However, this is not a chemical reaction because it is simply the vaporization of water.
There's evidence of a chemical reaction in our cookies with the small air bubbles that you can see there, like right there, with the small air bubbles in them after they have finished baking. In baking, this is usually either an indicator of air or carbon dioxide trapped inside of them. So in this case, the oven is very hot, causing the water in the cookies to evaporate. The vapor then creates bubbles in the cookies. The vaporization of water is a physical change, but the bubbles are also evidence of the presence of carbon dioxide, which can be confirmed by looking at the ingredients we used. We used baking soda and baking powder in our recipe. Baking soda reacts with acids in the batter to leaven the cookies by producing carbon dioxide. In this case, the baking soda likely reacted with the sour cream, which is made with fermented dairy products, so it would react with the baking soda. The baking powder has both baking soda and an acid within it, so that reacts with itself. They don't need to react. They do not react unless dissolved in a liquid in the batter. But baking soda also leavens the dough, so that is why there's these little bubbles in them. So it's carbon dioxide and water vapor.
So for our cookies, since we're modeling the Lofthouse cookies, we want them to have like a light color because when you buy them from like Kroger, they're like white, you know. And so this is why
Here, there's like a slight difference in the color of the cookie, and definitely a difference in the dough color. So this is like
this is like would be a cake flour, and then this is like all-purpose flour,
and this is bread flour, which you can see like.
Something that affects the color is pH, and pH is a measure of acidity of a solution based on its hydrogen ion concentration, and it's shown on the scale, a specific pH scale, which is 1 to 14. It's calculated by taking the negative log of the concentration of the H3O plus, which is hydronium ion, in a solution. The scale is logarithmic, so a change of 1 pH unit corresponds to a tenfold change in the H3O plus concentration. The scale defines a solution as either acidic or basic. Acids have a pH of less than 7, bases have a pH of greater than 7, and neutral solutions have a pH of 7. One of the properties of acids is having a sour taste, while bases have a bitter taste. Both acids and bases are used in cooking. For example, baking soda, or sodium bicarbonate, is a base. Some baked goods, such as croissants, want to have a golden brown color where a pH of 6 to 8 is most desirable. In our experiment, our goal is to have the pale tan color, so that would be achieved with a lower pH. The low pH of the sour cream we used in our cookies neutralizes the high pH of the baking powders. However, in the case that there is excess baking soda left over after this reaction, the degree of the browning of the sugars during baking would increase. So we used bleached flour and bleached cake flour in our second trial to help prevent farther browning from that reaction. The low pH of the bleached flours can help neutralize any excess ingredients that have a high pH, making the overall pH of our cookies lower and giving them a lighter color.
Okay. Where is this? This is the cake flour. Where did I put the rollers like invisible? What the heck?
I found it!
Oh my god! Yeah, I think so. And
Thanks for watching our show!
Woo!